Hello class, this is an example video for probability tree diagrams. So let's get straight into it. A coin is rigged to land tails up 60% of the time. Draw a tree diagram simulating 2 coin throws of this particular coin. And then we're going to be calculating the probability of getting heads heads or tails tails or one of each heads or tails. Let's draw this now. So we're going to have 2 coin throws. Here's our first. Here is our second. Our first coin toss could either be heads or it could be tails. After our second coin toss, it could also either be heads or tails. Same with the tails. After tails, it could either be heads or tails. Let's draw these branches leading into them. So from heads, like so. There we go. Now, because this is a rigged coin, we cannot leave the probability tree to look like this. Probability trees that look like this assumes that heads and tails in both coin tosses are equally likely. Because of this, because we know that this is a rigged coin and tails land 60% of the time, we can write this 60 as 0.60, okay, or just 0.6. So along this branch, heading towards tails, we write 0.6. Well, if it lands 0.6 times for tails, then the remaining amount must be 0.4, because both of these outcomes, have to add up to 100%. Well, after the heads, it could be heads again, which is again 0.4, and tails is 0.6, and heads here is 0.4, 0.6. So now to get the probability of heads and then heads, we follow the branch, 0.4. We multiply that also by 0.4. And this will give us 0.4 times 0.4, 0.16. To get the probability of getting 2 tails, we follow the branches, 0.6. We multiply it again by the same branch we're following, 0.6. This will give us 0.36. Now for the last one, the probability of getting one of each, heads and tails, we could either get heads and then tails, or tails then heads. So we can either get heads tails like so, or we could get tails heads. Because it's either, we could add the probability, so this is the same as probability of heads tails plus the probability of tails heads. So heads tails is 0.4 times 0.6. We're going to add to that 0.6 times 0.4. Inputting all of this, That's 0.24, 0.6 times 0.4, that's also 0.24. Adding these together, we get 0.48. Hope that gave you a better insight into probability tree diagrams. Best of luck.